Alright everybody, welcome back. This is video 2 from section 7 of unit 2, derivatives of cosine of x, sine of x, e to the x, and the natural log of x. In the last video we kind of explored the derivatives of these functions and tried to guess what they were. And then we developed the derivative rule for sine of x. If you haven't watched that, you might want to go back and watch that. And today we're going to continue, or in this video we're going to continue, and we'll start by developing the derivative of cosine of x. This is going to look very similar to the development of the derivative of sine of x. We're going to start off again with the limit of the difference quotient. So we're going to take the limit as h approaches 0 of cosine of the quantity x plus h minus cosine of x all over h. And then we need to use a trig identity. And if you don't know this one's a little bit harder than the one with the signs, but the cosine of the quantity x plus h is cosine of x cosine of h minus sine of x sine of h. And we of course still have the minus cosine of x there. And all of that's over h. And now, just like we did when we were deriving the rule for sine, we're going to group the terms that contain cosine of x into one limit and the other terms into another limit. And so this is going to become the limit as h goes to 0 of cosine of x cosine of h minus cosine of x, all that over h. And I'm going to make this a minus since we've got a minus sign here, minus the limit as h goes to 0 of sine of x sine of h all over h. And now, since both of these terms contain a factor of cosine of x, I can factor the cosine of x out in that limit. And so this becomes the limit as h goes to 0 of cosine of x times the quantity cosine of h minus 1 all over h. And this is still sine of x sine of h over h. And now I'm going to take the cosine of x and sine of x and factor them out of the limits, because since the limits are with respect to h, those are both constants in terms of the limit, so I can factor them both out. We'll bring a cosine of x out in front here. And bring a sine of x out here. And now we already know what both of these limits are from our previous example. We know that the limit as h goes to 0 of cosine of h minus 1 all over h is 0. And the limit as h goes to 0 of sine of h over h is 1. And so simplifying all of that, we end up with negative sine of x. And therefore we have just proven our rule. The derivative with respect to x of cosine of x is equal to negative sine of x. Okay. Next, developing the derivative of e to the x. Okay, so again, we're going to use the definition of the derivative. So f prime of x is equal to e to the x plus h minus e to the x all over h. Oops, forgot my limit. Limit as h goes to 0. And then, let's see, how can I simplify this? Oh, exponent properties. E to the x plus h is equal to e to the x times e to the h. Now we normally use our exponent properties in the other direction, but this is a very helpful way for us to use this property that, if I multiplied e to the x times e to the h, everybody here can tell me that it's e to the x plus h. We just add the exponents. Well, yeah, we can go the other way and break that apart accordingly. And now, since there's an e to the x in both of the terms, I'm going to go ahead and factor an e to the x out of both of the terms. And then e to the x is constant with respect to the limit, so I can use the constant multiple rule for limits and bring that e to the x out in front. And then I just need to know what the limit of e to the h minus 1 over h is. I try to substitute numerator 0, denominator 0, so I've got the indeterminate form. So I'm going to go ahead and use my calculator to help me find this limit. So I'm going to go ahead and type it in. Let's go e, where's e? There's e. E to the x minus 1 over x, and we want the limit of that around 0. So I have my table set around 0, and it looks like these y values are approaching 1 as we get closer and closer to 0 from both sides. So we're going to say that that limit is 1, and therefore our derivative is e to the x. And so we've now verified the rule that we speculated about, and that is that the derivative of e to the x is e to the x. Now, this last one, the derivative of the natural log of x, I mentioned last time that I was going to give you a lot of help on this one. This is kind of challenging to do with the limit of difference quotient. So what I'm going to actually do is very briefly rely on a technique that you're going to learn later on in Unit 3, a technique known as implicit differentiation, and I'm only going to use it one time very quickly in this, but we're going to use the rule that we just found for e to the x as well as implicit differentiation, and that's going to enable us to find this derivative rule. So first I'm going to define and say, let's let y be equal to the natural log of x. If so, I can take this equation and raise this equation e to both sides, and it's still equivalent. E to the y is equal to e to the natural log of x because y and natural log of x are equal to one another. And then we should know from our pre-calculus course that e to the, or even earlier, e to the natural log of x is equal to x, and therefore this leads us to the equation e to the y is equal to x. Okay? Now from here, what I'm going to do is I'm going to take the derivative of this with respect to x. On both sides. Now we should know that the derivative of the right-hand side, the derivative of x with respect to x, is just going to be 1. The derivative of e to the y is very closely related to what we just found in this rule up here, with one little twist. And that one little twist is that since we're taking the derivative with respect to x instead of the with respect to y, there's going to be one little extra piece to our derivative. So let's take the derivative with respect to x of e to the y. The derivative of e to the x is e to the x. The derivative of e to the y is going to be e to the y times the derivative of this exponent, which is dy dx. Now why don't we see that normally in the rule? Well, we do. If we took the derivative with respect to x of e to the x, it's equal to e to the x times the derivative of x with respect to x, which is just 1. Okay? More on that later on when we learn about the chain rule and implicit differentiation. This will all make a whole lot more sense to you. All right, so I'm going to go ahead now and solve for dy dx. I divide both sides by e to the y. And then I go back to this statement right here. E to the y is equal to x. So I'm going to replace this e to the y with an x. And I end up with my rule dy dx is equal to 1 over x. And therefore we've verified the rule that the derivative of the natural log of x is equal to 1 over x. So those are our 4 rules from this lesson that you're going to need to know. The derivative of sine of x is cosine of x. The derivative of cosine of x is the opposite of the sine of x. The derivative of e to the x is e to the x. And the derivative of the natural log of x is 1 over x. Okay, let's get into the examples. Example 1, find the value of f prime of pi over 6 if f of x equals 3 cosine of x minus 2 sine of x. So we're just going to apply our derivative rules straightforward here. We're going to find f prime of x is equal to 3 times the derivative of cosine. The derivative of cosine is the opposite of sine. So 3 times the opposite of sine is negative 3 sine of x minus constant multiple 2 times the derivative of sine of x. The derivative of sine of x is cosine of x. It's minus 2 cosine of x. And then we're going to go ahead and substitute pi over 6 in there in place of x. And this becomes negative 3 sine of pi over 6 minus 2 cosine of pi over 6. And man, you remember all those circle charts you did in pre-calc? Oh boy, are those going to come in handy now in calculus, because we're going to frequently be evaluating trig functions at these important locations. So we're going to evaluate, and the sine of pi over 6 is 1/2, and the cosine of pi over 6 is the square root of 3 over 2. And this simplifies out to negative 3/2 minus the square root of 3. And that is our value for f prime of pi over 6. Okay, and let's do example 2 yet, and then we'll call it quits, and we'll finish this lesson up in a third video. So let's look at example 2. Find the value of g prime of 2 if g of x is equal to 8e to the x minus 4 natural log of x. So first I'm going to find g prime of x. The derivative of 8e to the x is 8 times the derivative of e to the x, and the derivative of e to the x is just e to the x. So the derivative of 8e to the x is 8e to the x. Minus 4 times the natural log of x. So we take the derivative of this. We've got a minus 4. That's a constant multiple. And the derivative of the natural log of x is 1 over x. So that's just going to be minus 4 times 1 over x, which is minus 4 over x. And so then g prime of 2, we just substitute 2 in here. And we end up with 8e squared minus 2 as our final value for g prime of 2. All right, we'll call it quits for this video here. We'll see you next time, video 3, where we'll go through a little bit more information and our last example of the lesson. And I'll see you then. Have a great rest of your day, and enjoy yourself.